ever pondered over the intricacies of cross-site scripting, commonly known as XSS? It's a term that can send shivers down the spine of even the most seasoned web developers. XSS is a type of security vulnerability that can be exploited in web applications, allowing hackers to inject malicious scripts into web pages viewed by other users. This is more than just a developer's concern. It's a potential threat to anyone who browses the internet. For instance, imagine clicking on a seemingly harmless link, only to find out later that it has allowed a hacker to steal your personal data. That's the power and the danger of XSS. Understanding XSS is vital, not just for web developers who need to safeguard their applications, but also for the general public. It's a key step in maintaining a safer, more secure, digital world. In the coming scenes, unravel the complexities of the three types of XSS: reflective, stored, and DOM-based. First, dive into the world of reflective XSS. Reflective cross-site scripting, or XSS, is a type of web application vulnerability. In this scenario, an attacker manipulates a URL in a way that causes the website to respond with a page containing injected script. This script is then executed within the victim's browser. Imagine a scenario where an attacker sends a crafted URL to an unsuspecting victim. The URL contains malicious JavaScript code, which gets reflected back in the response when the victim clicks the link. The victim's browser executes the script, allowing the attacker to steal sensitive information or perform actions on behalf of the victim. The potential impact of reflective XSS is substantial. It can lead to session hijacking, identity theft, and even defacement of websites. The key to remember is that reflective XSS exploits are only active as long as the malicious link is clicked. Reflective XSS, though dangerous, is just the tip of the iceberg. Let's delve deeper. Now shift the focus to stored XSS. Stored cross-site scripting, or stored XSS, is a more persistent and often more dangerous form of XSS. Unlike reflective XSS, which relies on tricking users into clicking a malicious link, stored XSS involves the injection of harmful scripts directly into a website's database. Let's illustrate with a simple example. Imagine an online forum where users can post comments. A cybercriminal posts a comment containing a malicious script. This comment, along with the embedded script, is stored in the website's database. Now, every time a user visits the page containing that comment, the script executes, potentially stealing sensitive information or taking control of the user's session. This is the insidious nature of stored XSS. The malicious code is stored and served directly from the targeted website, bypassing many of the usual security checks. Stored XSS can be a silent but deadly threat. But there's more to XSS than meets the eye. Finally, explore the realm of DOM-based XSS. Here, the danger lies not in the server side but in the document object model, or DOM. This model allows scripts to dynamically access and update a web page's content, structure, and style. So, how does DOM-based XSS work? It happens when a web application's client-side script writes user-provided data to the DOM. If this data isn't properly sanitized, an attacker can include malicious scripts that the browser will execute. Consider this example. Let's say a website uses JavaScript to display a user's search query back to them. If an attacker inputs a script instead of a standard query, this script could be executed, potentially leading to data theft or other damage. DOM-based XSS is particularly elusive because it doesn't involve the server side at all, making it harder to detect with traditional security measures. DOM-based XSS can be elusive and potentially harmful. So how can you protect yourself from these threats? Protection is better than cure, especially when it comes to XSS. Now, let's delve into the various techniques to prevent cross-site scripting attacks. First, input validation. This is a method where you check and sanitize the data coming into your application. It's like a bouncer at a club, only allowing the right kind of data in. Next, output encoding. This is your second line of defense. It ensures that any data sent out to a browser is displayed correctly and not executed. Think of it as a translator, converting any potentially harmful scripts into safe text. Now onto security headers. They're like your castle's ramparts, adding an extra layer of protection to your application. They instruct the browser on how to behave when handling your site's content. Lastly, regular updates and patches. Software, much like a garden, needs constant care. Regularly updating your software helps ensure you're protected against any newly discovered vulnerabilities. Remember, staying vigilant and informed is your best defense against XSS attacks. Stay safe and keep learning.